This comes out of section 3.3, Rates of Change in Natural Science. So for this example, it's kind of a physics example. We're given this definition of something called linear density. And truth is, I never ran into this in physics myself ever, but it's just a unit of mass divided by length. So nothing too complicated. I guess it talks about the kind of the general thickness or mass per unit length of a rod of metal or a rod of pipe or something like that. And so your units end up being, in this case, kilograms per meter. And so they use the unit, some fancy little Greek letter here, M over L. And so what you'd find is that if you had a uniform rod that was the same the whole way down, you could say, oh, this thing is 1 kilogram per meter, or if it was a thicker, fatter rod, it was 7 kilograms per meter, or something to that effect. If you had a more interesting rod mathematically, it would be, changing in thickness and whatever, so you might have a relationship between mass and length. In this case, we're given a relationship that is mass equals length squared. And so our linear density, if you look at this at some particular point on the rod, would be dm by dl. Whereas, for the first one, let's try an average density. The average density of this rod from a spot where it's from 2 meters up to 2.3 meters. Well, we know average density doesn't really require calculus at all. We're just going to say how much mass over how much length. And sorry, I should use L all the way through here. And so I've got, that this is going to be 2.3 squared minus 2 squared divided by 2.3 minus 2. So in other words, kind of like the slope of a secant line if we were looking at this graphically. And it gives me about 4.3 kilograms per meter. So on average from that spot where the length is 2 to 2.3, we have a linear density of 4.3. Now for question B, if they ask the linear density at 2, at L equals 2, then what we're looking at then is dm by dl when L equals 2. So the function, m equals L squared, relatively easy to differentiate. The derivative is 2L. And so our linear density is going to be 2 times 2, which is 4 kilograms per meter. So again, the difference between finding a slope between 2 points in the first example, the average density one, and then the slope at a point, essentially with the derivative for the second example.